Hi, everybody, and welcome to the first webinar in the series where we will take a look at leveraging SIEM to hunt and neutralize cyber threats. Hopefully, it won't be the last webinar in the series, but we are going to hope to do a few of those in the future. My name is Luka Harmicar. I'm a SIEM product manager and product owner at Infigo, where we work mostly with Splunk as a security and data management platform, and we are developing our SIEM on top of it. And today we are going to talk a little bit about some incident responses from the field, taking a look at the real life examples, and we can take a look at the introduction now. Slide, yeah. So today we are looking at actual real world attacks, and this is primarily because they are the most useful kind of data for developing new detection rules and actually developing the SIEM and its detection possibilities. This first webinar will be a little lighter on the technical side because we are going to look at an attacker that is not as mature and as proficient as probably as a red team engagement or an ATP. This is a low-level attacker where he manages, he uses, let's say, tools that are easier to detect. He uses techniques that are not really discrete and we can easily find them and detect them. We will also check out how this looks in the SIEM, regardless of SIEM that you are using. Here we are going to use Infigo SIEM on Splunk, and we are going to talk a little bit about the detection capabilities and how to improve the detections based on real-world data on the attacks and IOCs that we find in the environment. And now I will give a little overview of the story, so it's not only dry. So this specific case happened after Corona finished. Everything returned back to normal. People needed to get back to the offices, but of course, in IT, a lot of us tasted that nice life working from home, and of course, some of the people had a hard time adjusting to that. And in this story, there was a developer that wanted to work from home for, let's say, 2 weeks. And he asked his admin if he could get an instance from which he could to which he could connect from internet and, of course, access the required resources for his work. And unfortunately, the solution that they chose was to have an RDP server in the DMZ from which you could connect to the internal network and of course work as needed. Of course, that was a temporary solution that became permanent one, and the server unfortunately became a target of a brute forcing attacks after a while. And about the incident now, the attacker was in the system for 5 months, so quite a long time, and he did not really follow any playbook or rules of engagement, if you would like, and he was more using the method trial and error, where he would download different tools, run different software and see what worked, what didn't work. He would have gaps where, let's say, he would not show up in the environment for 2 or 3 weeks, and then he would come back and try something else. So he left a lot of evidence for the incident response team to follow later. So we see from this information that he was still a hacker who is not really proficient. He does not use any stealthy techniques. Rather, he is only downloading the tools, using the things that other people developed, and he does not really care about detection, or he does not really have the knowledge. So he is the hacker in learning, as mentioned here. And the client did not have any SIEM or log management, which made the incident response pretty hard, and there was a lot of digging from different machines and getting the logs from different machines and analyzing them manually. And the main goal of this incident, from this attack, was destruction, theft, and ultimately blackmail for financial gain, where the attacker tried to blackmail the company into giving him money in order to unlock the files. We are going to take a little look at the TTPs that he was using, so it is easier to follow it after in SIEM. So the initial access, as mentioned, was through the RDP server, where the attacker managed to brute force the password of a local administrative account. And the funny thing is, it's not really funny, but the attacker did not really use any command and control software or tools. He simply installed a remote management solution, a real VNC, to achieve persistence and continuous access to the environment. And there was no real need for command and control, and everything was done through the remote sessions. Afterwards, when he gained the access, achieved persistence, he started to discover different assets on the network, and for that he used a lot of different tools, but SoftPerfect network scanner was one of them. And then he started to move laterally through the environment, logging into different RDP servers with the local admin account that he found, that he got the password from in the initial brute force. And also, unfortunately, that was also true for some Linux servers where the password was the same for different accounts. And in all of those systems that he connected to, he installed different remote management tools, Real VNC, Altera, Splashtop, AnyDesk, and there was a few of them. And I know that I said previously that he didn't really care about the detection, but he tried to clear the Windows event logs. He was deleting the logs from the various tools that he was using. So that was his way of performing defense evasion and making life harder for the incident response team that came after him. And once he was when he was logging into different machines, of course, he tried to perform credential harvesting, with Mimikatz module, and he was generally successful. He found different accounts, and one of them, unfortunately for the victim, was the domain admin account. Over that time, he was exfiltrating data. There was several terabytes of data that was exfiltrated from the client. And for that, he used the MegaSync tool with Mega Cloud. This software simply syncs everything that you put in a folder on your computer to the cloud, similarly as Dropbox or any other tool for that matter. And then in the end, as he got the domain account, he used group policy to push to all of the Windows domain joined assets, crypto malware, the ransomware malware that was named SVC host, but with a 0 instead of the O, and he locked a lot of data, of course, from different computers, and then wanted a ransom in order to unlock them, to give the client the unlock key. Okay, this is generally all from the presentation that we have, and now we are going to take a look at the SIEM, how it works, and what can be in generally detected in the environment, and how the detections work. So here we will have only the detections for this particular case. And of course, if we go back to the first attack, that was a brute force, generally you can detect that using detections that we call excessive failed logins, where for specific account there is a lot of failed attempts at authentication. And of course, if that is some local account, which usually they are, you can easily find if there is a brute force attempt currently in the environment. If we check out how these events look like in general, here is of course a detection that we wrote for this specific case. But in Windows, you can detect that easily with event code 4625, which are failed login attempts. And of course, you will see the address from this is coming from, so this is something external. We can see the source name, and of course, if the computer name that is trying to authenticate to your machine is Kali, you can probably be certain that this is some sort of attack. And we see that all of the requests are failure. And of course, there can be a detection. We have a detection for brute forcing detected, and in general, this is the same as excessive failed logins, but it also looks that there needs to be a successful login attempt after all of the failed ones. So if the attacker manages to also log in after all of the failed ones, then this rule will trigger. Of course, we have seen again excessive failed logins after, but this was triggered because before the successful attempt there was also failed ones. And now the client is in the environment. The attacker is in the environment. He managed to find it. He logged into the server, and he installed the remote management tool. We can see that it was the real VNC software that was installed, and this can be again generally easily detected with either Windows or with Sysmon. So for Windows, you will have to enable additional logging. For Windows, it is 4688 event code. And this will log every process start in the environment. So if anytime any process starts, this will log it, and you will be able to see any process that is running on any machine that you are collecting data from. Or you need to collect Sysmon, and then it's event code 1 that finds all of the different processes that start in the environment. Sysmon in general is better. It gives you more information, but of course it requires the installation of additional agent, and that agent is now the Microsoft is responsible for Sys internal project. So the Microsoft is responsible for it. It's not a, let's say, third party. It is a legitimate tool that you can use, and a lot of teams use it. And now if we simply look for VNC server, we should find anytime that the server was VNC server was started or the process did something, and we can see the first time, of course, when this happens. And from these alerts, if we check out our alert, in general, it does not use the data directly. Rather, it will read it from the table that holds the summary of all processes that have ever started on any machine. This is summary information about all the processes in the environment, and this is generally useful to find those quick detections. Because let's say you have a rule for remote management software, and if you have 20 different executables that you want to find, then it's much easier to look at the table than to look through potentially million of events, and this will be faster. So this is why we have a summary table that will hold all of the information about different processes running in the environment. And this way you can also get the information when the process was first seen and so on. After the remote management tool was installed, he actually added it to the scheduled tasks. So he added a scheduled task that automatically runs the tool every time the server restarts. So this way, he is sure that if anything happens to the server, his tool will again start on the next startup. And for this, you again need to log Windows stuff. Sure, stuff. You need to take a look at the event code 4698, and again, you will have to configure logging for this event code manually because it is not enabled by default. And what this gives you is it will show you all of the new scheduled tasks that are created. You can also log the updates to scheduled tasks and the deletion of scheduled tasks. For the beginning, I would recommend that you only log the creation of scheduled tasks because the updates can be really noisy. And if you are using Splunk, as in general we are, and our SOC is using Splunk, you really have to take care of the license, and you don't want to be in the breach, or you of course want to save money on the license as much as possible. So we are only logging for 698, which is the new scheduled tasks. Scheduled task has been added. This detection is actually pretty new in our SIEM, and the reason for that was we fortunately have a red team in the company, and we are fortunate enough to perform some purple teaming engagements from time to time. And there was a pen tester that was performing the tests. He said, I expect that you are going to catch this step, because he added his beacon to the list of scheduled tasks, and we were like, we are not going to see it. We do not even log that information in Splunk, rather alone have a detection for it. And then he was really surprised, because he mentioned that for every beacon, whenever they are using it in the environment for Cobalt Strike or anything, they will always either create a new scheduled task or try to update the existing ones if they want to be stealthier. So after that, we of course enabled the collection and created a detection for it. And as mentioned before, oh, no, sorry, share screen. I misclicked, unfortunately, and stopped sharing for the moment. I hope that we are back. So once he was done, of course, we mentioned that he tried it to make life a little bit harder for for the incident response team that will come sniffing for him afterwards. He tried to clear the logs on the machines that he was using. As mentioned, he was cleaning the tools, different tools that he was using, and the different event logs also. And this detection is, in general, it's a must, because almost always it's a true positive, since there is no reason in general to clear the event logs on Windows hosts. There are some cases where the clients will clean them because they have too little disk space on some of the printers or whatever. But in general, these cases can be excluded from the detection, and this will almost always be a true positive. It is the Windows event code 1102, and it is logged by default. As the attacker was moving through the environment, as he was moving through the environment, he of course used Mimikatz to try and gather credentials, and in general he was successful because since he was a local admin on most of these hosts already, he had the adequate privileges, and he could disable the antivirus that would in general shut down the standard version of Mimikatz that you would download from Git. In this case, he executed the Mimikatz through Lasagna. It is a called tool. It's a tool that it has a lot of different modules. Mimikatz is just one of them. And in this example, in this detection, we executed the Mimikatz through memory. So for this to work, for you to be able to detect this, you need to have Sysmon. So this can't be detected only with Windows events, unfortunately. And this is unfortunately true for a lot of more advanced detections that let's say a SOC team would want to have in their arsenal. A lot of them will require Sysmon, and they will need to have logs from Sysmon devices. In this case, this detection will look at the image loaded event code and the process accessed. Let's see, process accessed event code 10. So what this detection does, it looks at the libraries that Mimikatz uses for credential dumping, and it looks if the process will target LSAS at the same time. So if LSAS is targeted and all of the libraries for Mimikatz are used, or these are usually some cryptographic libraries, then we can assume that this is a detection for Mimikatz. There are some antivirus softwares that do perform this same setup, and they can usually be excluded in the beginning. Okay, and as we are nearing its end, now our attacker has access to the domain account. He can log into the domain. He started exfiltrating data. And now this is a topic that is a little harder to detect automatically. And this is why something like threat hunts are useful in the environments, because some things it's much easier to find if you are looking for them and you know what in general you are looking for. So let's say that you wanted to find exfiltration activity in your environment. There are two ways. You could use again Sysmon, and unfortunately Sysmon will not tell you how much data was exfiltrated from a specific machine. It will simply log it will simply log the information about the network connections coming from different machines, and from that you could try and figure out if the machine is performing some sort of exfiltration based on the network activity alone. Let's try and fasten this up a little bit. Based on the activity alone. So if there is a lot of network connections in some period of time that is not historically there, you could take a look where are those connections going to, why are they happening, did they happen in the past, and so on. The other thing where you can see the exfiltration would be in general on the firewall, of course, the logical place where a lot of people will look. And the interesting thing there would be to check the size of the data that is being exfiltrated from one machine to the to outside to the web, and then try to correlate that to historic data to see if it is an increase, and to find which processes are performing the exfiltration. In our case, this was done with MegaSync, and if there was a detection that looked at amount of data that's exfiltrated, you would find that you have MegaSync on that device, and you would be like, okay, that is weird. This is not something that is approved by the company. Also, one of the things that probably could be a detection at this point is you could write a rule similar to this one, where you would look at different software that is used for syncing data between the local machines and the cloud, because most of the organizations today use at least some sort of cloud backups, or they have services that run in the cloud. For example, we have OneDrive, and a lot of other companies probably too. But if OneDrive is something that is generally used in the company, of course you could exclude it and run a search that will try and find all of the different software that is used for cloud syncing, and then alert on it. Because if it's not approved by the company, why would anybody have such a software installed? After the exfiltration in general was done, he pushed the client, the attacker pushed the crypto malware to all of the hosts in the domain. He downloaded, of course, the executable, put it on a share, and then used the GPO to execute that software on every machine that had access to that specific share. And here, one interesting rule actually detected because of his naming of the software, because it was a fuzzy match, since he just changed one letter in the very known Windows process. This rule could detect it. And in general, this was it. At the end, the attacker requested the ransom from the company, and this was in general the end of the attack. And this is in general the end of the stream. I hope that you learned something or saw something new. And I hope to see you again in the next webinar. Thank you. Bye.